Hello, today is May 20th, 2024. Today we're going to cover physics. We're going to talk about electric field. Okay, in this time, we're going to see how charge is being distributed in the ninth segment. And then, let's say this is a length L, charge Q. How does the ninth segment carry a charge Q? They have a specific electric field at a specific point. Let's say this is a point B. This is what we try to do. Again, when we set up this, we can put whatever we want, but in order to simple the calculation, what we set up is the following. The P actually is in the middle of the 9L. So in other words, that will simplify our calculation. Why? Because let's say if we put take a little bit dq right here, that dq based on our electric field calculation formula, we know that actually point to that direction, right? That's our dE. But the thing is, we can decompose to two components. One is in the x component dEx, another one is dEy. And then if we at another side, we put the same dq, and then that dq can actually have the similar components. One is x, one is y. So the y component is going to be cancelled. The x component is going to be superposition. So that's the basic idea of how to find the dE. And then after we get the superposition, the dEx, we just integrate from here to here. And then we will get all the electric field due to this charge, whatever you call it, charge pole or charge ball. Okay, so with that being said, let's walk into the details. This we call it x direction, this we call it y direction. Again, this is a perpendicular. Okay, so first we look at the dq, which is randomly selected. Okay, and then the distance from here to here, which is y. The distance from, again, this is origin, from the origin to the point P, that's called x. And then again, this is going to be r. Recall from the previous calculation, the dq is what? The dq is a little bit charged here, like very, very small amount of the charge. And then we're going to integrate from here to here, right? And then that actually equal to the charge density. Remember we used lambda before? This is for the charge density. Okay, so the charge density times dL. L is the length for this direction. In other words, since we already put this as our y coordinate, so which is the same as lambda times dy. Okay, so once we know what is the dq, and then we can plug in the further. So the dE will be equal to k times dq over r squared. R is this distance from the little dq all the way to point P. That's our R. So again, according to the Pythagoras theorem, because this is a 90-degree angle, so the R squared actually equal to x squared plus y squared. Because this is the y, this is our x. Okay? Again, since we interest in the x components, right? The x component. So we need to further find out what exactly the x component is. So it's going to be dx, which is whatever we have right now, dq over r squared, times the x components will be the dE times cosine theta. Cosine theta. And then that will be equal to k dq r squared. What is cosine theta? Because this theta is the same as this. Cosine theta is going to be adjacent 9 segment over the hypotenuse. So that is going to be x over square root of x squared plus y squared. Okay? Now, let's put everything together. It's going to be k over r squared, because this is inside also r squared too. So this part is going to be x squared plus y squared 3 over 2. Because this is the, if you consider this as the square of this, so that's that. And then the dq, what is the dq? dq is right here. It's lambda dy, and then times x. Okay. But what is the lambda? Lambda is the charge density. It's the whole charge of the ball over the length of the ball, right? So let's plug that in. It's going to be q over L, and then x, and then dy. Because this is this two position does not matter if we switch them, because they are implied the multiplication in between them. So we can do something like that. And then here would be x squared plus y squared, and then 3 over 2. Now we need to find an EX. How do we find an EX? We integrate dEX. How do we integrate dEX? Like this is a definite integration. It's going to be negative half L. Why? Because the total length is L here. This is a positive y direction. This is negative direction. So since this is cut in the middle, so we know it is from negative half of L, integrate all the way to positive half of L. So half L dE, and then that would be integration positive half of the L, and then dEx would be this guy right here. Will be K Q X L it's going to be x squared plus y squared 3 over 2 dy. Okay, so this is a little bit complicated. In particular, for those who never learned calculus before, it's going to be very challenging. But if you already took calculus class, then after I explain this, hopefully it makes much more sense to you. Number one thing we have to pay attention when we see this is we've got both x and a y. But here, the only variable have is y. Even though both x and y look like both variable, but actually here x is the distance from the origin to the point P. So x is the constant right here. Since it's constant, we are going to take them out. So k is constant, q is total charge is constant, x is also constant too. Of course, L is the length of the bar, so it's also constant. So what we left is half L to positive half L, and then x squared plus y squared dy. That's what we have. How do we integrate like that? So again, this is a required second level of the calculus class, which is talking about like the integration techniques. Here we have to use the trig identity. So let's say if we let y equal to tangent set x tangent set. Why I let y equal to that? Because if I let y equal to that, then x squared plus y squared is going to be what? It's going to be x squared plus y squared is this guy, right? It's going to be x tangent theta squared. And then that would be equal to x squared plus x squared tangent theta squared. And then we can factor x squared. It's going to be 1 plus tangent theta squared. This is a trig identity. 1 plus tangent theta squared actually is secant theta squared. Okay. Now, don't forget we actually had a power of 3/2 right here. Okay, so again, I'm going to copy this so that way you guys can still follow this. So what we had before is Ex equal to KQX. Again, this is just a copy of the previous calculation. And then dy over x squared plus y squared. Okay, since x squared plus y squared, see this is what we did before, right? X squared plus y squared, we did all the calculation, go to here, is equal to x squared secant theta squared. So x squared plus y squared to the power of 3/2, which is this guy right here, that actually equal to x squared secant theta squared to the power of 3/2. And then that would be x secant theta 2, because these both have 2, we can take it out, times 3/2. So what we have is x secant theta to the power of 3. And then indeed, that is x 3 secant theta 3, right? Now, we need to look at the dy. What is the dy? Since we let y equal to x tangent theta, right? Since y equal to x tangent theta, dy, again, x is constant, so it's constant. this again is the required capability of your calculus knowledge. So when you take the derivative of tangent theta, actually it's just equal to secant theta squared. Okay, so if you don't know this, then if you learned the calculus before, go review your textbook. But if you never took the calculus before, then you need to learn calculus to be able to understand this. Okay, so dy is now we plugging everything back to this equation right here. So it's going to be kqxl from half of, again, here, I'm not going to write on this. Why? Because we changed the variable, right? Oh, by the way, there's a d theta right here. We change the variable from y to theta, right? So this and this actually the corresponding to different limits, because the variable is different. To simplify the calculation, I just say, this is from A to B. I know this is the limits regarding to the variable theta. You might understand why I didn't calculate the specific one, because I try to simplify my calculation. So I know I change it to new limits, and then my dy will be this guy, will be x secant theta square d theta. My x squared plus y squared to the power of 3 over 2. Where is it? Is this guy right here, go all the way to here. That's x cubed secant theta cubed. So notice this x we can cancel 1, so this become 2. And then secant we cancel. So what we left is the following, is kqx L, new limits A to B. So what we have is x squared, this is secant d theta. Okay, that's what we have. Notice secant theta is equal to 1 over cosine theta. So this is indeed, can flip the cosine theta up. So what we have, before we do that, this x, we can cancel out 1, right? So this become 1. So again, x is constant, we can move on. So what we have is kql x, new limits a, b, cosine theta, d theta. Again, here require another calculus knowledge when you take the integration of cosine theta, actually indeed to sine theta. So it's going to be kqlx sine theta with new limits from A to B. Okay, now look at this. You know what, I just draw this again. This is x, this is a p. So those A, B, when we're talking about theta, right? So this is the theta. This is the theta. And then this is the AB is the limits when the variable is theta. However, the sine theta, actually, when you're moving from these limited points all the way to the tip of the bar, the sine theta, in this case, actually corresponding to this 9 segment divided by this 9 segment. So that's sine theta, right? So in this case, we know sine theta, we know this one is half of the L, right? So the sine theta actually equal to half of the L. divided by the r right here. What is the value of the r? Based on the Pythagoras theorem, is this guy the square plus this guy square. And then take the square root of it, right? So it's going to be square root of this guy is half of the L square. And then this guy is our x, right? So it's going to be plus x squared. So that's our sine set. Here, actually this part is a negative value, right? That corresponding to the limit b, okay? So in other words, if we go back to e x, that's equal to kq lx sine theta limit b subtract sine theta limit a. And then kqlx sine theta to b actually is this guy right here. It's L over 2 square root of, we can take this, that would be half of the L squared plus x squared, right? And then subtract what's the value of right here, the sine theta a. Sine theta a, everything else is the same. It's the same length for r, but it is only this part. This is a negative value. So it's going to be negative L over 2 over exactly the same length of r, which is L over 2 squared plus x squared. And then if we combine those together, because once you subtract a negative, which is the same as plus the positive, half L add together is going to be L. L and this L is going to be cancelled, right? And then this leave is the same common denominator. So the final result would be KQ L, no L, because this L is this L being cancelled, just the KQ, and then we get X right here, right? And then we get a square root of, we can, take care of the square. So that would be L squared over 4 plus x squared. So that is going to be the final result for this calculation. Notice even though it's just a bar right here, so when we're doing a calculation, we have to not only understand the physics, but also must have a relatively strong mathematical background. So notice we use the trig identity, we use the integration, and then we also use the trig substitution of integrations. And how do you know this? I think one of the ways is practice more. Another thing is in the future when I'm talking about the calculus, I'm going to talk more about it. Hopefully you guys can understand calculus better. But right now for the math part, I'm going to start with the algebra and the geometry because that's the most of students had trouble with. With that being said, please subscribe and also leave the comments so that way the program can continue moving up. Thank you so much. Talk to you later. Bye-bye.